Here's the next session, steps to graphing rational functions. So here are some steps to graphing rational functions. So you can copy these down, or you can let me talk about them first, and then you can write them down, and I'll try to talk about them real fast, right? So first one, find the vertical asymptotes. Set the denominator equal to 0. Find horizontal asymptotes or oblique asymptotes. Talked about this in the last video. Horizontal asymptotes. We look at the degree of the numerator and degree of the denominator. If the degree of the denominator is bigger, then it is y equals 0. If the degree of the numerator and denominator are the same, then it's the lead coefficient of the numerator divided by the lead coefficient of the denominator. And then if it's oblique, that means the numerator degree of the numerator is bigger than that of the denominator. So then you actually have to use synthetic division or long division to go ahead and divide that. And then what will happen is your answer will be whatever your quotient is, minus the remainder. So if you take off the remainder, that oblique asymptote will be a linear equation. Finding the y-intercept by evaluating f of 0, that means plugging in 0 for x and solving. Finding the x-intercepts, this is kind of, it might seem a little hard because we just dealt with polynomials, and polynomials were difficult. But all we have to do here is really set our numerator equal to 0. So if we set the numerator equal to 0, then we can find those x-intercepts. Number 5, this is what I kind of talked about, where the horizontal asymptote can be crossed, but then it comes back and approaches that horizontal asymptote just from the other side. So how you do that is you set your function, okay, your fraction equal to, you're going to take this fraction of whatever your function is, right? You'll have a numerator and denominator, and you'll set that equal to the y value of your horizontal asymptote. So if my horizontal asymptote is y equals 2/3, then I'll set my fraction equal to 2/3, and I'll solve for x, right? How do you get rid of your denominator? Well, you multiply both sides by your denominator. So then I would distribute 2/3 to all my terms in my denominator, and then I would solve for x. Okay, so that's how you test. So what will happen is, when you do that, at the end, you'll either get x equals something, or you'll get a number equal another number. So like -1 equals 2, right? So that means it won't cross. Okay, number 6 here is to plot some points, right? And I've said this before, when you have your graph, if you have your vertical asymptotes, you just plot a point over here, plot a point over here. If I have 2 of them, two vertical asymptotes, then I plot maybe a couple points in between 2 vertical asymptotes, but then I just plot a point over here. And you can plot more if you want to, right? But once I know one, I know it's either going to go up towards the vertical asymptote or down, right? And it's not going to cross the horizontal one unless step 5 says it's going to cross, right? And then I'll talk about little kind of what I talked about before. Our graph either goes up towards the vertical asymptote or down, right? Or it goes up and up, depending on the multiplicity of our factors of our denominator. Okay, and then once we graph some points, then our graph is pretty much done, right? So there you go. So the end behavior, I'll do some examples here. So the end behavior, what this behavior rational functions is talking about if we look at the denominator and we look at our factors, say we have these factors, x plus 3 cubed, and then say there's an x out here. Okay, so we have 3 of them. So that means we would normally just set each of these factors equal to 0, right? And that would give us our vertical asymptotes. Right? So, and as long as I don't have the same up here in the numerator and they don't cancel out, right? Then they're vertical asymptotes. So x equals 0, x equals 2, x equals -3. So then if I was to graph those, I would go over to 0, x equals 0, plot my vertical asymptote through here, x equals -3, x equals 2. So I'd plot those, okay, right? Now I told you sometimes you have to graph a couple points in between here to see kind of what the graph does. Well, this little behavior of rational functions says that if we look at the multiplicity of each of these factors in the denominator, 3, 2, and 1, well, what it says is when we approach that vertical asymptote, whatever the multiplicity of each factor, if it's odd, then our graph is going to come up towards the vertical asymptote, and then on the other side of the vertical asymptote, it's going to go down. Okay, so then I would just have to plot one point in here, and if it's down here, then I know it's going to go this way, and the other side's going to come up. Okay, if I plug in a point and it's right up here, then it's going to go approach that one. Maybe I should do at x equals 0, right? Because that's my one I'm talking about. So right here is 1. So this has a multiplicity of 1. Okay. So at x equals 0, if I plot a point over here, say -1, and it's up here, that means my graph is going to go towards that vertical asymptote, and on the other side it's going to go down. So that deals with anything that really has an odd multiplicity. So even at -3, I would test a point, say right here. Let's use a different color. Test a point right here at -3, and then if I'm below, down here, then it's going to go down, and then on the other side it will come up, right? So that kind of helps you to know what's going on in between here, because then I can get a point, plot that point, and I know it's going to come down and back up in the middle of those two vertical asymptotes. Now on the right, it is a squared, right? So since it's a squared, what that means is on either side of the vertical asymptote, it's either going to go up and up or down and down. So what's nice about this one is once I plug in a point, I can still test a point right here and test a point right here. And then I would know it's going to go up and up, or if it points down here, I know it's going to go down and down. Okay? So there you go. That's how you can use the multiplicity of the factors of the denominator, right? So as long as those are vertical asymptotes, then we look at the multiplicity and see if it goes up and up, or on either side of the vertical asymptote, or one goes down and one goes up, or one goes down, yeah, one goes up. Okay, so here's some graphs. We're asked to graph these. So first thing, vertical asymptotes, right? See if you can factor first, even though this is both linear. We can see if we can factor first. We can't, so we set the denominator equal to 0. We solve for x. X equals -3, so there's a vertical asymptote. So if you want to, you can graph that at the same time. Go over -3, put your vertical asymptote through there. Okay, and then we have our horizontal asymptote. The degree of the numerator is the same as the denominator, so it's going to be y equals the lead coefficient over the lead coefficient. So that's 2 over 1, which is 2. So up at 2, I have my horizontal asymptote at y equals 2. Now I can graph some points to the left of that and to the right of that. Like I just talked about before, since this is a multiplicity of 1, right? The degree, that's a linear factor there, so that means it's going to go up and then down, or down and then up. So I can plot a point, say I can plug in 0 and see what I get. So 0 times 2 is 0, 0 plus 3 is 3, 0 plus 3 is 3, so I get 3 over 3, so I get 1. So at 0, I'm up at 1. So I know I'm right there. So the one thing I have to do, I probably should have did before I plotted that point, but it's okay. I need to set my fraction 2x plus 3 over x plus 3 equal to the y value of my horizontal asymptote, because I need to see, does this cross it or not. So I plug in my y value is 2. Now I solve this, multiply by the denominator of both sides, x plus 3. And now I get 2x plus 3 is equal to 2x plus 3. Or 2x plus 6. Make sure you distribute to both of them. Okay, so what's going to happen here is the x's are going to cancel out, so I get 3 equals 6. That's not true, so that's not going to cross. Okay, so then I know I can finish my graph. It's going to approach that vertical asymptote. Remember, that's not a flat line, it's curved, right? No two y values are the same there. And then it's going to approach this vertical asymptote down there. So that means I know, because this is linear, that this side is going to go up towards that one, right? So now I just need to put a x value into my equation. So say -4. So -4 times 2 is -8. -8 plus 3 is a -5. And then plug in a -4 here. -4 plus 3 is a -1. So -5 over -1 is a +5. So at 5, 1, 2, 3, 4, 5. Up here, it's going to go down to the horizontal. I know it doesn't cross because that's what I just did right here. And then it's going to go up because that is a linear. It only has a multiplicity of 1, right? So there's my graph, done. All right, this next one, 4 minus 2x. Try to fool you here. F of x equals 4 minus 2x. So see how that's not in standard form, so you could switch that to standard form if you want to. And then 8 minus x, that also is not in standard form, so you can move those both into standard form if you'd like. So that would be f of x is equal to negative 2x plus 4 over negative x plus 8. So then it's in standard form, right? So then I can look at my horizontal asymptote. These are both same degree, so it's going to be lead coefficient over lead coefficient. So again, it's y equals 2. My vertical asymptote, see if you can factor first. Can't factor anything, right, out of both of them. So we just take the denominator, set it equal to 0, and we get x is equal to 8, right? So x is equal to 8. Then we can go ahead and graph those on a graph. So at x equals 8, 1, 2, 3, 4, 5, 6, 7, 8, I have my vertical asymptote, and y equals 2, 1, 2, horizontal asymptote. Check to see if our equation, negative 2x plus 4 over negative 8 plus 8 equals our horizontal asymptote, which is 2. Multiply both sides by the denominator, you get negative x plus 16 negative 2x plus 16 equals negative 2x plus 4. These x's are the same on both sides, right? So if I added 2x on both sides, the 2x on both sides will be canceled. We get 4 equals 16. That's not true, so it's not going to cross that line. Now we can plug in anything. Probably I want to plug in x's that are close to these vertical asymptote, maybe one on each side, so maybe 9 and 7 into our original. So negative 2 times 7 plus 4 over negative 7 plus 8. So that is negative 14. Plus 4 is negative 10, and we get a positive 1, so negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so something like this, down this way, and it's going to approach that way. That looks terrible, but that's okay. And then plug in, well, I plugged in 7. Oops, sorry, guys. So negative 10 and 7, something like that. So it's going to approach that way and come up this way, something like that. Now plug in 9. 9 times negative 2 is negative 18. Negative 18 plus 4 is negative 14. And then negative 9 plus 8 is negative 1. So negative 14 over negative 1 is positive 14. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, so at 9 we're at 14, so it's going to go up towards that way. And then this would be way out here, and it's going to go closer and closer to that horizontal asymptote way out there. Okay, so here are some more graphing. So factor first, so we get x plus 1 over x minus 6. What are the factors of negative 6? Add up to 5, so that'd be a positive 6 and a negative 1. Then we divide those by 2. So that's 3, so x plus 3, and then 2x minus 1. So those can't cancel, right? So those can't cancel, that's fine. So you have vertical asymptotes. So find your vertical asymptotes, setting the both denominator factors of the denominator equal to 0. So x equals negative 3, that's a vertical asymptote, and x equals positive 1/2, that is a vertical asymptote. So we're going to graph those. And then we have our horizontal asymptote. So horizontal asymptote, the degree of the denominator is bigger, so that's y equals 0. So we can go ahead and put this stuff together and go ahead and start graphing. So vertical asymptote negative 3. So let's go and put stir, and 1, 2, 3. So at negative 3. And at positive 1/2. So positive 1/2. So right here, that looks good enough. And the horizontal asymptote at y equals 0. Put that in there. Okay, now we can really just make sure, check that our horizontal asymptote doesn't equal we don't have an x value that equals our horizontal asymptote. So multiply both sides by the denominator, we get 0. So we just get x plus 1 equals 0. So x equals -1. It does hit 0 at x equals -1, right? So at -1, we do hit the horizontal asymptote. Okay, at y equals 0 there. Okay, so now we can go ahead and plug in some points. We found one right there. And then we're going to go ahead and plug in some more points. We can plug in say -4, +1, and see kind of what happens. So let's plug in a +1 into this equation. So 1 plus 1 over 1 minus 3, or is that +3? I believe that's +3, and then 2 times 1 minus 1. See what that equals. That is 4 over 1 and 2 on top, so we get 2 over 4, so that's 1/2. So here's 1/2, so somewhere down here at 1. So we're going to approach that horizontal asymptote that way and go up towards the vertical that way. We don't cross it right there. Okay, let's plug in a -4. So a -4, -4, -4. So that is a -1, -3, -8 minus 1 is -9. So that's 1/3. So 1/3, +1/3. So positive, here's 1/3, somewhere down here, right below that one. So it goes towards the horizontal asymptote, up towards the horizontal asymptote. Okay, so we do kind of have a point in the middle of those two vertical asymptotes. We can use it, and then we can just use the fact that, hey, this is an odd vertical asymptote, right? X equals 1/2. That only had one multiplicity, right? So that means if this side goes up, that means this side from here would have to go down. Right, so it would have to go down from that point. And this also at x equals -3 also has the factor is just, notice this factor is just 1 to degree 1, this factor is to degree 1. So if the left side of that horizontal asymptote or vertical asymptote x equals -3 goes up, that means this side, well, hold on, let me check real quick. Oh, okay, so let's come back real quick. Oh, negative times a negative, that's a positive, right? So that's a positive, and you got -3. So that's actually -1. So that's actually -1/3. Okay. So I need to erase that. So that's actually -1/3. So we're actually down here. So this side goes down, and this side goes up. Over. That it's not an L, right? It's actually kind of curving there. Okay. So why I had to redo that one is because I saw that, hey, this is x equals -3 is only a multiplicity of 1, so it should, one side should go up and one side should go down, right? So this side should go up, this side should go down. Okay, so there you go. There's the graph of that one. Now we can do the other one. Okay, so you factor first. Okay, so factor the top one, we get -18. Factors of -18, that up to -3. Since this is negative, we're really subtracting the 3. So what times what is 18, but subtracts the 3? That'd be a -6 and a +3, right? But because this is negative, that means we need the bigger number's got to be negative, so -6 and a +3. And then we divide by our a, so we get x -2 and a x +1. And then it has to be x times x is x squared, so that 3 is actually coming out, because you could actually divide all those by 3 to begin with. Okay, and this one is x +4. X +4. So nothing cancels here, so that means these denominators, when you set them equal to 0, they will be vertical asymptotes. So x equals -4 is a vertical asymptote. And I could rewrite that as x -4 quantity squared, right? So that means I have a multiplicity of 2 right there. So that means at my vertical asymptote there, let's draw some regular lines first. So at x equals -4, we have a vertical asymptote. x equals -4. We have a vertical asymptote, and since this is squared here, that means either we're going to go up and up, or we're going to go down and down. Okay, so then we just need to find our horizontal asymptote and go from there. So horizontal asymptote, we 3, 4. Okay. Horizontal asymptote, we have to look at the denominator of the numerator and the the degree of the denominator and the degree of the numerator. They're both the same, so we take the fraction of the coefficients 3 over 1. So y equals 3 is your horizontal. So 1, 2, 3. There you go. So 1, 2, 3. All right. So now we can go ahead and plot points. We can plug in 0, see what we get. We just need to make sure that we don't cross our horizontal asymptote. So we have to set our equation equal to 3, because that's what y equals. Y equals 3 for our horizontal asymptote. So we set it equal to that, and we have our 3x minus 3, or x minus 2, sorry. X minus 2, x plus 1. Right? X plus 1, yeah. Okay. Right. Over x plus 4 quantity squared. Okay, so if I multiply by the denominator on both sides, we get 3 times x plus 4 quantity squared equals 3x minus 2. So I'm going to FOIL those out, so we'll get them back pretty much to the original where they were. So this would be 3x squared plus 24x plus 48 equals 3x squared minus 5x minus 6. Right? Yep. Oh, minus 3 in the middle, sorry. Minus 3x in the middle. Okay. Then our x squareds are going to cancel because we have on both sides. We add x on both sides. So we get a 27x, subtract 48 on both sides. We get 27x is equal to 27x is equal to negative 54. Divide by 27, we get 2, and it's a negative 2. So at x equals negative 2, it is going to cross. So at x equals negative 2, we are going to cross 1, 2, right here. We're going to cross that right there. Okay, now that we know where it crosses, now we can just plug in some points, right? So I can plug in 0, plug in 0. I probably want to plug in 0 into the original one, right? Because 0 would be 0 here, 0 there, so I get negative 6, 0, 0. I get negative 16 over, or sorry, negative 6 over positive 16. So that is a negative. That is a negative, what, 3/8, negative 3/8. So something smaller than 1, right? So negative 3/8, so somewhere probably in there. Oh, negative 3/8, sorry. Negative down here somewhere. Okay. So then we go ahead and finish this because I know I'm gonna cross, right? Because it's hitting right there, so that means I can go ahead and plug in a negative 3 and see what happens. So I'm actually gonna plug in the negative 3, not back into the original, you can, but I'm actually gonna plug that negative 3 back in here. So I'm gonna plug that negative 3 not into the original, but into the factored form. So x minus 2x plus 1 times 3 over x plus 4 quantity squared. So I want to plug that negative 3 in here. So I want to plug in negative 3. I get negative 5. I get negative 2. And I multiply those, I get 30 on top. Negative 3 is 1, so I get 30. So at negative 2, I'm at 30. Or sorry, not negative 2, negative 3, I'm at 30. So negative 3, I'm at 30. So that means I'm somewhere way up here, right? So I'm going to cut through here. I'm going to go through these 2 points and I want to approach that vertical asymptote, right? Okay, but I got to come back and approach the line. I always approach the asymptotes, right? So I can't come down and continue on right here. Okay, I got to come back and approach the asymptote. And you can see that if I plugged in, say, a positive 2. If I see a positive 2, I know I'm probably actually going to be somewhere up here closer to y equals 3. So if I do that, I'm going to get 3 times 2 minus 2, which is 0, right? So that makes this whole thing 0. It doesn't even matter what the top is. It doesn't even matter what the bottom is. I get 0, right? So I come past here and see how I get 0. So I'm actually getting closer. And then if I plug in a bigger number, I can see that what's going to happen is I'm going to come back and approach that asymptote through there. You can't see it very good because that label's on there. So you go through 2, 0, and you're going to approach that asymptote. You're always approaching the asymptote. So when you cross it, you just cross back and you come and approach the asymptote. Okay, so if we know this is, because this vertical asymptote was a squared, right? We had a multiplicity on that. Since we're going up on this side, that means we also have to go up, right? So we know this is going to go up on this side as well, so we're coming down and approaching that. Now let's just find a point somewhere in here. So if we plug in, what, 5? Let's plug in 5. So let's erase this 2 because we knew what that was. Let's plug in 5. So that's 3. 3 times 3 is 9. What about 3 plus 1? That's 4. That's 36. So we get 36. Okay, on bottom we're plugging in 5, right? 5 plus 4 is 9. Okay, 9 squared is 81. So 36 over 1, or 36 over 81, let's figure that out. I'm all kind of scrambled here. This is negative 5. Oh, well, hey, 36 over 81, that's fine. 36 over 81, that's less than half, right? So I plugged in a positive 5, my mistake, that's okay. I plugged in a positive 5, so if I go over to 5, this thing's annoying me. Okay, I'm probably annoying you. But if you plug in 5, so there's 3, 4, 5, I get less than half, right? So I get less than a half. So I'm somewhere, I get somewhere less than, well, what is 36? Let's find out what 36 over 81 is. Okay, so I don't know where the last time I actually paused this video, because I was talking for a while and I came back and it was on pause, so I don't know where I left off. Sorry about that. But I'm going to plug in negative 5. Maybe last time I plugged in 5 and I try to graph that as negative 5, but now I'm actually going to plug in negative 5 into this formula, into this equation, right? So negative 5 minus 2 is negative 7. Negative 5 plus 1 is negative 4. And then over x plus 4, so negative 5 plus 4, negative 5 plus 4, quantity squared. So that's negative 1 squared is 1, so 7 is 28. 28 times 3 is a little less than 90, right? So at negative 5, we're at a little less than 90. So at negative 5, negative 5, we're somewhere way up here, right? So that's good enough. That's fine. Probably if I plugged in something bigger, like say negative 10, I would actually get something closer to graph. But that's okay. Okay. So I think that's, here's some more. I just did this one. Right. So I think that's probably good. Here are some more homework problems on page 355. On page 355, these are the ones that I want you to do. Let's do these. 83, 63, 67, and 87. Yeah, go ahead and do those 4 on page 355, and then I'll play the rest of the video of me actually doing this. Okay, so here's 63 and 67. Alright, so vertical asymptotes, nothing cancels here. On the one on the left, on 67, you can factor that to x minus 2x plus 1. Again, nothing cancels. So we set these factors. Alright, so here's my factor right here. Here are my two factors on 67. They have a degree of 1, so you could use that. Right, they have a multiplicity of 1 each, so you could use that when you're graphing, after you graph your vertical asymptotes. But we set those vertical, to find those vertical asymptotes, we set these equal to 0, so that means x equals 3 is a vertical asymptote on that one, x equals 2, and x equals negative 1. So we go ahead and graph these. After I do these homework problems, I'll come back and do some extra problems, the ones that I skipped over, that I said I wasn't going to do. So I'll go back and do some of those. So if you need extra help, you can watch those videos of me doing those problems. Okay, so now we need a horizontal asymptotes, okay? So we look at the degrees of the numerator and denominator and see which one's bigger. On 63, they're the same, so it's y equals the lead coefficient divided by the lead coefficient, which is 1. Here, the denominator is bigger, so it's y equals 0. Okay, so we can start to graph both of these. We go ahead and put down our vertical asymptotes and our horizontal asymptotes. Okay, so vertical is x equals 3. So 1, 2, 3. Okay, and for this one, it is 2 of them, x equals 2, so 1, 2, oops, sorry. 1, 2. And x equals negative 1. Okay, so let's put those on. Negative 2, or positive 2, negative 1. Okay, good enough. Okay, horizontal asymptotes at y equals 1 and y equals 0. Let's put those on. Okay, then we just have to test. Ooh, that looks beautiful. And just have to test if we set our fractions equal to our horizontal asymptotes to test them. Alright, this one's kind of nice, the one on 67, because when we set this equal to 0, the denominator, when we multiply both sides by the denominator, it's going to be 0. So we get x equals 0. So at x equals 0, on this one, it actually does cross. Right here. Okay, on this one, we set this one equal to 1, 63 equal to 1. Okay, when we multiply, we get x minus 3. By the denominator, we get x minus 3 equals x plus 2. And so the x's are going to cancel out, so we get negative 3 equals 2, so that means it doesn't cross. Okay, so now we can really just test some points here. I want to plug in 0 into this one on the right, on 63, because plugging in 0 is not too bad, right? 0 plus 2 is 2. 0 minus 3 is negative 3, so we get 2 negative thirds. So negative 2 thirds, so that's negative 0.67-ish. So at 0, we get negative 0.67, so somewhere down here. And now we can just approach that one and approach this one. Since this is odd, right? This was a degree of 1 on the factor there. That means the other side, if one goes down like this one did on the left, on this branch on the left, the right branch is going to go up, and this one would come down to the horizontal. So we can go ahead and plug in what, 4. So 4 plus 2 is 6, and 4 minus 3 is 1, so we get 6. So if we go up 6, there's 1, 2, 3, 4, 5, 6. So we can make a better adjustment here on our graph. And so we go up towards the vertical and down towards the horizontal. So there you go. There's that graph on 63. Okay, 67. Again, we're just plugging in numbers, right? So we're plugging in numbers to the left and to the middle and to the outside. So here we have negative 2. So if we plug in negative 2, these ones are a little more difficult just because there's more to the problem, right? So we get 3x. So we have 3x over, I want to write the factored one. You can write the normal one if you want. Sometimes I like the factored better. It just depends on the problem. So x minus 2, x plus 1. So x minus 2, x plus 1. Okay, so I'm going to go ahead and plug in, what did I say, -2. So -2 minus 2, that is -4. And -2 plus 1, that is -1. And a -2 times 3 is a -6. So I have -6. I have -6 over -4 times a -1. So I get 6 over -4. So that's -1 point something. So -1 point something. So there's -1 point something a little more, right? So somewhere right there. That's terrible to the left and down to the right. That looks ugly. Let's curve it more. There we go. See, make it a little curvy, right? It's not an L or a sideways L or an upside down L. It's curvy. I'm just not very focused right now. I apologize. Okay. Anyways, let's move on. Let's go ahead and plug in. We already know what the middle one is, right? And because these are degree 1s, right? These factors are a multiplicity of 1. Each factor is a multiplicity of 1. So then we know if the left branch goes down, that means the right branch is going to go up. So that means this one is going to go up this way, and then we can plug in a number to the right. And because that has a multiplicity of 1, I'm pretty sure it's probably going to go down on the left of that vertical asymptote at x equals 2. Okay, so let's go put in 3. Let's plug in a positive 3 this time. So if we plug in a positive 3, ooh, man, sometimes this thing annoys me. 3, we get 9. 3, we get 1, right? So we get 9 over 1 and 3, so we get 3, right? So at 3, we get 3. 1, 2, 3. There we go. So we know it goes up towards that one. A little curvy that way. There we go. So if this side goes to the right of the vertical asymptote, goes up. Since it's a multiplicity of 1, this side would then be going down. So there's the graph. If you want to, you could plug in a positive 1 and see what happens. You could plug in, yeah, that would be enough, positive 1. And you can see what it does. So there's the graph of 67. Okay, so here's number 83. It's already factored for you, right? So here, right, it's already factored for us, and none of the factors cancel. Then we look and we set the denominator is equal to 0, so we have x equals 1 is a vertical asymptote, and x equals -5 as a vertical asymptote. I'll go ahead and put that graph already up here. That's not cool. Regular one. So if we go over 1 and -5, 4, 5, okay. Now we can put those down at 1, at -5. Okay, horizontal asymptote. This one you kind of have to think through, right? So if we multiply this one, it would be x times x, so we'd get an x squared on bottom. And if we FOILed the top out one, we get an x squared, so it's really the same. And since they're just x's by themselves, if we FOILed out, their coefficients would be 1 and 1. So our horizontal asymptote would be y equals 1. So at 1, we can go ahead and draw our horizontal asymptote. Now we just have to set that equal to our fraction here. So we set this equal to 1. Multiply, right? That means we're pretty much setting the denominator equal to the numerator. So x plus 4, because we're dividing by x minus 1 times the quantity x plus 5. So we need to multiply that, and multiplying by 1 is the same thing. So this one I'm actually going to have to actually FOIL this out, because I need to try to get x by itself. So when I FOIL it out, I get x squared plus 8x plus 16 equals x squared plus 4x minus 5. So the x squareds, because I have them both sides, right? If I subtracted x squared on both sides, the x's squareds would cancel out. Then if I go ahead and move my 4x over, x's to one side, I get 4x minus my 16 on both sides. So I get 4x equals -21. Divide by 4, divide by 4. So we get what, like 5 point something, so 5 point blah 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 blah, -5 point something. So at x equals -5 point something, we do hit that y equals 1. So there's 5, So a little more than 5, we do hit it, right? Okay, so it does cross there on number 83. So 83, it is going to cross on that. Now we can go ahead and start plugging in points. So we can plug in 0, see what happens at 0. 0 plus 4 is 4. 4 squared is 16. 0 minus 1 is a negative 1. 0 plus 5 is 5. 5 times negative 1 is negative 5. So that's negative 3 point something. So negative 3, 1, 2, 3, negative 3 point something. So a little more than 3 at 0. Oops. A little past that, didn't I just say? There you go. All right. So, you know, it's probably going to come down here, approach that vertical asymptote. I don't quite know what it's going to do to the left, right? So maybe I should plug in a positive or negative 1, 2, 3, 4, negative 4. So plug in a negative 4 into it and kind of see what's going to happen here. So let's plug in a negative 4. So a negative 4 plus 4 is 0, right? So that's awesome. So 0 divided by anything down here is still going to be 0, right? So at negative 4, we are at 0. So at negative 4, we're at 0. So maybe it's going to kind of come back around. Maybe I don't know yet. That's why I should look at the multiplicity, right? And the multiplicity is 1. Okay, so that's going to come in handy. So maybe I don't quite know where the graph is going to go yet on 83, but I'm assuming it's probably going to come back down. So it's probably going to go through this point, and then, you know, it's not going to look exactly like that, but maybe come down like that or something. Okay. All right, so now we can go ahead and find out what's on the other side of negative 5. How about negative 6? We'll see what happens at negative 6. So let's plug in negative 6 into our equation and see what happens. Okay, so we go and plug in negative 6. Negative 6 plus 5 is a negative 1. Negative 6 minus 1 is a negative 7. Negative 6 plus 4 is a negative 2. Negative 2 squared is 4. So we get 4 over negative 7 times negative 1 is 7. So 4/7. So that is less than 1, right? 4/7 is less than 1. So we are less than 1, just barely less than 1, somewhere around here. So we plot that point. We know it's going to cross, right? But then it's going to come back towards the vertical asymptote and towards the horizontal asymptote. So maybe you don't know. I mean, what I'm assuming is the graph probably is going to go like this, and then this one's going to come back and approach that horizontal asymptote, and then this one, because this x equals negative 5 is not a multiplicity of anything, I'm feeling that it's going to come across here, and eventually it might look something like that, probably is what I'm kind of suggesting. And we can check that out more by plugging in more points, right? So if I plug in, say, a negative 10, right? So that's negative 5, 6, 7, 8, 9, 10. A negative 10, I can see what happens even more, right? So if I plug in a negative 10, I can really see what happens here. See if it comes back and approaches that. Right, so a negative 10. Okay, negative 10 plus 4 is 6. Negative 6 squared is 36. Negative 10 plus 5 is a negative 5. Negative 10 minus 1 is a negative 11, so that's positive 55. So I have 55 over 36, so 36 over 55. Right, so that's a small fraction, right? Again, that's small. It's a little, probably bigger than 1/2. So that's coming back, right? It's coming back closer at negative 10. We're somewhere in here, right? So it is coming back and approaching that line. And it's probably going to get smaller and smaller and smaller as we go along. And so then it's got to approach, it's got to cross, right? Because it did cross. We found that. It does cross. And then it approaches that vertical asymptote there. So it approaches that vertical asymptote. Okay. Then we can go ahead and plug in a number, say, to the and it only crosses once, right? So that we know in the middle that it's not going to cross it, right? So it's not going to cross that horizontal asymptote again. And since this x equals negative 5 is a degree of 1, right? It doesn't have any multiplicity. That means we are going to come back down here, right? So we're going to go and we're going to come back and go down this way. Right, so we know we're not going to cross that, so it kind of looks like that, and it can be very rough, right? In calculus, when you go on to calculus, you'll actually kind of figure out where those hills and valleys are exactly located. They're called local mins and local maxes, and we will find those in calculus, but right now it's more of a rough sketch of these. Okay, so let's go ahead and plug in a positive 2. So let's plug in a positive 2 into these and do the math here. So positive 2 plus 4, that is 6, and a 6 squared is 36, right? And then over here, down here, we have a positive 2 plus 5 is 7, and 2 minus 1 is 1, so we get 36 over 7, so that's almost 36 over 6, so that's, 5 point something. So it's 5 point something. So 1, 2, 3, 4, 5 point something, a little more. There we go. So we're coming down this way, approaching our graph, and coming up this way, approaching that vertical asymptote. So there's number 83. So these, can get a little complicated, but again, if you don't know what's happening, plot more points. If you can find your vertical asymptotes, okay, and find your horizontal asymptotes, then just start plotting points. See what you get. If you don't know what it looks like, plot more points until you have the shape, right? One other thing other than the vertical and the horizontal, I have to take the horizontal and set it equal to my fraction, set it equal to the rational function, and solve for x. Okay? But if you can't do that, that's okay. At least start plotting points. Plug in x's and see what you get. See what's happening. Plug a couple points on this side, few points in the middle, few points over here. If you still don't know, plug even more points to the left, more points in the middle, more points on the right, until you have the shape, right? Until you get your branches of these rational functions. All right, let's do 87, and then I'll come back and do those other ones if you need more practice. Okay, so here's number 87. These are oblique, right, because the numerator is bigger than the denominator, so if you want to stop here and not do this one, I'm okay with that. But if you're going to plan on going on to calculus, then I'd recommend practicing these a little bit more before you get into them next year. Okay, so like I said, there's no horizontal, okay, but there is an oblique, so that means I have to divide these, right? So you can do long division or synthetic division. I like synthetic division, especially if you have, as long as you have a linear on bottom, you can do synthetic division. If you didn't, then you have to do a long division. Okay, so 1, 0, 1, 0 in the second row. And what goes in the box is your vertical asymptote. So set this equal to 0, subtract 3, minus 3. So there we go. We already have our vertical asymptote at x equals negative 3. Okay, run that through. 1, negative 3, 9, 10. Okay, so then we write your quotient. So y equals x squared, or not x squared, sorry, just x, right? X minus 3, oops. Oh, now x minus 3, and then plus your remainder, 10 over x plus 3. Now this remainder doesn't matter because as we get bigger and bigger and bigger, or bigger and bigger negatives, this is really not going to matter. So this equation, y equals x minus 3, that linear equation is our oblique asymptote. So the oblique, I think there's an I before there. Oblique asymptote is y equals x minus 3. All right, so it's a linear equation. We can graph that linear equation. So we go negative 3 is our y-intercept, and then we go up 1 over 1 because that's our slope. And now I can draw my graph. So that oblique one is going to be straight through here, straight through those 2 points. Come on, there we go, straight through those 2 points. So that's what it looks like. Okay, and now we can go ahead and find our vertical asymptote, which we already did, is negative 3. So at negative 3, 1, 2, 3, at negative 3, there's our vertical asymptote. So at negative 3, okay, there we go. That's the best way I can do it. All right, then we start plotting points, right? So remember, when we graph, it always approaches the horizontal asymptote and approaches the vertical asymptote on these. Okay. So here, like I said, this is a little tough. We would set x minus 3 equal to our fraction to see if it crosses that oblique asymptote or not, and x squared plus 1. over our denominator, which is x plus 3. So when we multiply by the denominator, x plus 3, that's a conjugate, so we get x squared minus 9 equals x squared plus 1. So the x squareds are going to cancel out. So no, it does not cross because I get 1 equals negative 9. So it's not going to cross. Awesome. Okay, so now we can plug in points. How about we plug in 0 and see what we get? So let's plug in 0 into our original. 0 squared plus 1 over 0 plus 3. So we get 1/3. So 0 is 1/3. So maybe somewhere right there. So I could really just stop right there. On the right. Then I would just need to plug in and say a negative 4. Negative 4 squared is 16. 16 plus 1 is 17. 4 plus 3 is 7. So 17 over 7, so that's 2 point something. So at 2 point something, so 1, 2, 2 point something, something right there. Okay, so what this is going to do, I probably need to extend these asymptotes a little farther than what they are. So let's extend this one. And let's extend this one. Okay, so that's going to help on that because we're at, negative 4, sorry. This is negative 4, so that's a negative 1, or a negative 1, not a negative 7, so that's a negative 17. So we're at negative 17 down here somewhere. All right, so at negative 4, we're at negative 17, so somewhere down, maybe down here. So this is going to now, remember, we approach, this is enough, because now we approach our asymptotes, okay? So we approach our asymptotes. So we go, in our branches, we always go in one direction and the other. So I could plug in another point here, say negative 1, and see what happens. But I can't approach the vertical asymptote this way or I'd cross, right? And I already know I can't cross. So that means this one has to come up. Oh, that was terrible. This one has to come up to the vertical, right? And I can't cross the horizontal this way, and I got to approach it. So it approaches it like that. This one, I can't approach the vertical like this because I'd cross my horizontal. So that means I got to approach the vertical this way. And I got to approach the horizontal, so I approach it that way. So there, I'm done with number 87. Okay, I don't think I'm going to go back through because I'm sure that was my wife texting me telling me to get home. So yes, it was. So I'm actually going to stop. If you want more help, let me know. You can send me a message on Edmodo, and I can talk to you about it. But yeah, we got to go.